Welcome to Atlas. This is the Atlas control room. Atlas is one of several experiments on the Large Hadron Collider. It's beneath my feet. It's about 80 meters beneath my feet is the level of the beam of the LHC. Nature has actually performed the LHC about 10,000 times on Earth, just by all these collisions of cosmic rays hitting the Earth. The problem is that it's been kind of hard to run around with a detector all over the place trying to catch these cosmic rays. And so that was why we decided to move forward and build accelerators and to produce these collisions ourselves. So that's why we do this.
You might know atoms have a proton and sometimes a neutron in the middle, okay? So that's called the nucleus. So we take protons out of atoms, we take them out of an atom, and then we accelerate them as fast as we can. So I would say if we're going to make millions of protons, maybe it takes, I would not know, maybe a day to get a clutch of protons together. So what we have to do is pull them away from these atoms, put them into an accelerator that zips them off to go into our big ring of the Large Hadron Collider.
We want to look at particles that we've never seen before. That means they have a higher mass. So what we do is we smash the protons together at very high energy. And it's the energy when it collides that can create a particle of a bigger mass. The higher the energy, the higher the mass. E equals mc squared. So the higher that energy, the higher the mass of the particle we can make.
We call it the Atlas detector, but really it's built up of a number of different component parts. In fact, there are 4 separate systems that go into the detector itself. On the inside, we have the tracking detectors. We then have things called calorimeters around that, and they're specifically to measure particles' energy. We have the muon spectrometers on the outside, designed specifically to detect muons. And then we put everything into a gigantic magnetic field, and there's 2 different types of magnets that go along with that. And really the way it works is like a gigantic digital camera, because we've got this amazing machine, the Large Hadron Collider, which we use to create the particles. And then as Steve told you, we might create something very interesting like a Higgs, but the Higgs doesn't stick around on its own. It decays into other particles. And to be able to see a Higgs, we need to pick up those other particles and then trace them back to the collision point and make sure that they came from a Higgs boson. And that's why we need such a complicated instrument like this.
There's so much more that you can get if you go to even higher energy. If you get up to 14 TeV and you get much more concentrated beams, you're going to have the possibility for more discovery. The higher in energy, the more possibilities for discovery.
How long does it take to collect and analyze the data after the protons have collided?
We collect the data. Our computers are working nonstop, and everything is done in real time. So there's an initial processing when there is an event, when there's a collision, where we take all these dots and all the data that's made all around the detector. We put that all together, and we get an idea that we saw something. And we then do that at CERN, and we gather it, and then we ship that data, once we think we've got something that's interesting, out around the world to different centers.
The internet, for example, is a product of CERN. This is something that was discovered at CERN, not because we were looking for it, but because when you do research on a large scale like we are doing here, imagine trying to share the information with all our colleagues. It's not easy. We needed a means to be able to pass the information to everybody all over the world. So the World Wide Web came up because we needed a tool like that to share the information. And CERN was really smart. It made it a gift to humanity. We didn't put any copyright or anything like that because, first of all, we are paid on public money, so it was normal to give it back to the people.